Quick review for section 3.1, solve systems of linear equations graphically. Those are our two objectives. We're going to focus on graphing both of the equations, so we get two lines, and we're going to also predict how many solutions there's going to be, one, infinite, or none. Alright, so you can pause it here and catch up on notes. I'm going to go ahead and explain this slide as I go through the examples. Same thing for this one. So if you need to pause it, copy stuff down, take your time reading through it, go ahead and pause the video. Otherwise, let's go and go through some examples. Okay, so our first example, we have a system 6x minus 2y equals 8 and 3x minus y equals 4. So the first thing we want to do is label. Okay, keep things nice and organized. So I'm going to label this equation A and this equation B. Next step is to make sure each one is into slope-intercept form. So neither of these are in slope-intercept form. The y is not by itself. So let's take A. So you have 6x minus 2y equals 8. Solve it for y. That means I'm going to subtract 6x from both sides. So you have negative 2y equals negative 6x plus 8. Divide every single term by negative 2. Continue to simplify. And you have 3x minus 4. Do the same thing for b. 3x minus y equals 4 is not in slope-intercept form. So I'm going to subtract 3x from both sides. So then you have negative y. Don't forget to bring the negative down. Negative 3x plus 4. Divide every term by negative 1. And you have y equals 3x minus 4. Transfer your information for slope and y-intercept into our chart. So you can see, and some you guys maybe already see this before I even write it, but the slopes are the same, and so are the y-intercept. The slopes are equal, and so are the y-intercepts. Well, when you have the slopes are the same, the y-intercept the same, you're talking about the same line. So in that case, we should get an infinite number of intersection points. So if you go through and graph this, that's what we should see. We should see two lines that are overlapping. So let's graph this now. X and Y. Pick a color for each line. So I'm going to begin at the y-intercept, which is negative 4. So I'm going to go down 4, 1, 2, 3, 4, put a point. Use my slope, rise over 1, 1, 2, 3, and over 1. And I'll go 1, 2, 3, over 1. One more just to get the best line that I can. There we go. So that's line A. Do the same thing for B, but you can see we've already done that. I'm just going to pick a different ink color. You would go to negative 4, go up 3 over 1, up 3 over 1, same line. So I'm just going to overlap this. And that would be line B. Pick a different color. So you can see they're overlapping. They have an infinite number of points in common. Right, so you'd write a statement saying since the two lines have the same slope, same y-intercept, there's an infinite number of intersection points. Okay, let's try another one. Okay, same process, so we're going to start by labeling, looking at if we need to change both or one into slope-intercept form. This one's already good to go. We don't need to change a slope-intercept form. The second one we do. So let's take B, 5x plus 2y equals negative 2, and we're going to solve it for y. So I'm going to move the 5x over. I'm going to subtract 5x. So I get 2y equals negative 5x minus 2. Divide every single term by 2. Simplify. Just don't forget the x. And then transfer the information into our chart. So for line A, my slope is negative 3. Which I'll write as a fraction. My y-intercept is negative 2. For B, slope is negative 5 over 2, and y-intercept is 1. So before we go through and graph, we're going to predict how many intersection points. Does it have 1? Does it have an infinite number? Or does it have none? the slopes are clearly not the same. They're different. These are different values. So if their slopes are different values, then we know there has to be only one intersection point. So you'd write your statement. Since the slopes are different, there's only one intersection point. Okay, let's go and graph it and prove it. Let me pick color. So I'm going to start at -2. That's my y-intercept. Go down 1, 2, 3 over 1, 1, 2, 3 over 1. And let's see if I can draw a straight line. Oops, sort of. That's A. Do the same thing for line B. Pick a different color. How about green? Go to -1. This time I'm going to go down 5 over 2. 1, 2, 3, 4, 5. 1, 2. Okay, I'm not going to be able to go down another 5 and over 2, so I'm going to have to stop. And you can kind of see it looks parallel, especially the way I draw. Okay, so this is where analyzing your information is super important, especially if you draw really messy like me. So can we say that they're parallel based on our graph? No, because if we look at the values of the slope, they're different. So we know there has to be an intersection point. So if we extend these, which I'm not going to go through and do, extend them, and I draw the graph better and I use a straight edge or ruler, they would intersect. Okay, so we'll leave that for later. That's a little bit more work we'll do in class. Let's try another one. Okay, so let me grab a different color again. Okay, so go through the same process. First things first, let's label it A and B. Figure out, okay, so in slope-intercept form? No. So we got to take each one and write it into slope-intercept form. So I'm going to subtract x from both sides. So you have -7y equals -x plus 6. Divide every term. Make sure it's a -7, not a +7. Simplify it. It's like a 1/7 minus 6/7. Okay. Do the same thing for B. So you have -3x plus 21y equals -18. Add 3x to both sides. That's plus 3x. Oops, sorry, I'm not going to do that just yet. So I have 21y equals 3x minus 18. Divide every single term by 21. You get y equal, that's 1/7 x. And so we can already see the slopes are the same. Let's see if the y-intercept is going to be same or different. Reduce it. So think of the biggest number that goes into both the numerator and denominator, which is 3. And you get 6/7. Okay, so as I'm writing this in the chart, you want to think, okay, well, what does that tell you about what the picture looks like? Because there's going to be one intersection point, infinite, or none. So the slope here, 1/7, -6/7. Slopes are clearly the same. They're equal to each other. So are the y-intercepts. So this tells us what? Tells us that there's going to be an infinite number of intersection points. The lines are going to overlap. Okay, so let's prove that by graphing it. Get some more practice from graphing. So let's look at the first line. So these are a little bit hard because I've got fractions to deal with. I'm going to start on the y-intercept, a -6/7. If this is -1, -6/7's here. And then my rise says go up 1/7. So you're going to go up the length of one side of the box. This is one box. So I'm going to go, one box would put me about there. And I'm going to go across 7. 1, 2, 3, 4, 5, 6, 7. So that would be line A. And then line B is the same. I'm just going to pick a different color. And it's just going to be the same line. Just going to overlap it. And that proves that we have an infinite number of intersection points.